Shalom to you. In this video, we will be using the distance formula to find the length of any line segment. This is the distance formula. It came from the Pythagorean theorem, where d is the hypotenuse and the change in x is one of the legs squared and the change in y. So remember the Pythagorean theorem, we have the two legs squared, the sum of them. So we have d squared, but when we take the square root of both sides, that's why the right side have a square root sign. And then the midpoint is the middle of a line segment. It is an ordered pair. So it's the median of the x, the 2 points of x, and the median of the y point. So let's solve problems. We're asked to find the distance between x and y, yz, xz. So here is x, and here is y. So we want to find xy, this length. So I encourage you to label your points. Like I label this x1, label this y1. So both of them has to be 1, 1. Then this point has to be the point 2, x2, y2. So if you write your distance formula, set it up and then substitute. Try to start by writing it first so that you see the numbers you are substituting. So here our x2 is 2. So we plug that in, minus, this minus is in the formula. Then x1 happens to be negative 2. So you need to do minus negative 2 all squared plus. Then our y2 is 4. Put that in. Minus in from the formula, and then y1 happens to be negative 4. So try not to skip any step at this time, so until you get a good feel of it. So work inside out, simplifying. So d equals 2 minus negative 2 becomes positive 2 plus 2, and then 4 minus negative 4 becomes 4 plus 4. So you add 2 plus 2, you get 4 squared, and then 4 plus 4 squared, you get 8 squared. So now you have the d is equal to 4 squared is 16, 8 squared is 64. You add them, you get 80. Now you take the square root of both sides. Oops, hold on. Alright, so we take the square root of both sides. Oh, this keeps going here. Alright, so yes, what can go into that? I think square root of, is that 16? Yeah, I think 16 times 5 will give us 80. So 16 times 5 will give us 80. And the square root of 16 is 4. Square root of 16 is 4, and then we keep the square root of 5 in square root sign. And that's the distance. Okay. So I'll have you try finding yz by yourself. This is yz. Find the length of it first. Alright, we're going to find the midpoint. Alright, before we find the midpoint, you can check your answer for yz. Okay, again, label the point and then plug into the formula x2 minus x1. So that's 2 minus 2 plus y2 minus y1. So negative 6 minus 4. So 2 minus 2 is 0 squared. Negative 6 minus 4 is negative 10. And then you square everything including the negative. You get 100. 0 squared is 0, sorry. 0 plus 100 is 100. And then you take the square root of 100, you get 10. So 10 is the distance between y and z. Now let's look at the midpoint. Let's find the midpoint of that line segment. Right here, let's find the midpoint of xz. This is x, this is z. So we want to find the median of this line segment. So have it written out here for x. Again, label your x1 y1, x2, y2. And then here is the formula, just add. Now remember, the distance one and the slope one, you're finding the change in x and the change in y, but here is you're not finding the change, you're finding the median. So you're going to add instead of subtract. So keep that in mind. So we just plug into our formula. We have our x1. So our x1 up there is -2 plus our x2 is 2. Again, watch the sign, divided by 2. Remember, this is ordered pair. Then our y1 is -4 plus our x1, our y2 is -6 over 2 in this ordered pair. So here we add -2 plus 2 happen to be 0 over 2. And then -4 plus -6 is -10 over 2. So 0 over 2 is 0. If it was 2 over 0, then it don't define, but we can have 0 on top. So this is -10 divided by 2 is -5. So the midpoint of this is going to be 0, -5. Does that make sense? So right here, the midpoint of that line segment.